We're a team of 4 members with a team number 8. As a part of this project, we've been assigned the algorithm Logistic Regression using gradient descent. The main objectives of this project are dimensionality reduction using principal component analysis and correlation matrix computed from the gamma matrix, to build logistic regression model using gradient descent approach, also to compare the accuracy and speed of the model built using logistic regression with that of SVM, which is an existing classification model of Python sklearn library. The project is to pre-process and to reduce the dimensions. We've considered 2 datasets consisting of past data of cancer patients. One consisted 100k records and this is used for training model. Another consisted of 1 million data records and this is used for testing model. You can have a look at the data. It was observed that there was no missing data. Raw data was used to compute the gamma matrix.
We have imported the required Python libraries. We'll have to compute the gamma matrix. Since there are 30 attributes in the cancer 100 CSV file, we have initialized the gamma matrix to a 0 matrix with 32 rows and 32 columns. The one extra row and column is used to store the outcome, which is the y, and the other extra one will be used in the predictive analysis. The gamma matrix generated on the entire X-train is equivalent to the summation of the gamma matrix generated on the chunks of the X-train. Now, we will need to compute a correlation matrix. Correlation matrix is calculated from the gamma matrix by using the following formula. And the next step is principal component analysis. The eigenvalues are calculated using a singular value decomposition of SVD function, which is shown here. Dimensions are reduced by considering the eigenvalues which are greater than 1. You can see the code here. And the next step is building the training model using logistic regression with gradient descent approach. The logistic function h of x is equal to g of theta 0 plus theta 1 x1 plus theta 2 x2 plus so on. It will continue on till theta n xn, where n is the number of the features, g is the sigmoid function whose y value is in the range 0 and 1, g of z is equal to 1 by 1 plus e to the power of minus z. Here, finding the right theta values is building the model in this case. The theta values are initialized with the random numbers and iteratively updates those values by trying to reduce the cos function. The gradient vector of the cos function is defined by the below formula. The theta values are updated by using the theta update formula. So here's the code to build the logistic regression model. And the next step is to predict the outcome of the test data. So take a look at the code for predicting the test data outcome. Now, we will have to predict the outcome by using an existing classification model. For this purpose, we have opted the support vector machine Gaussian kernel. There are 2 major steps which are involved. The first one is the train SVM model using the sklearn inbuilt Python library. And the second step is predicting the outcome of the test data by using the trained SVM model. Here, we have used the dataset of 100k records for training the model and the dataset of 1 million records for testing the model.
Here is the outcome of the project. Accuracy of logistic regression is around 93% and the time taken for this predictive analysis is 1.3 seconds. Accuracy of SVM is better than logistic regression and is close to 100. And the time taken is around 90 seconds and almost 90 times when compared to that of logistic regression. Contributions to this project are as follows. Analyzing both the datasets and computation of gamma matrix was done by Priya Gudivada. Understanding the concept of correlation matrix from the scratch was done by Vivek Siddharth. He is also a part of implementation. Implementing the correlation matrix followed by principal component analysis for dimensionality reduction was done by Sai Srija. Training the model using logistic regression and predicting the outcome was collectively done by all four of us. All the work related to support vector machine Gaussian kernel was done by Srihita. Report was report was collectively done by Sai Srija and Vivek Siddharth. Priya and Srihita contributed to the making of the video.
Though SVM is more accurate than logistic regression, but by leveraging gamma matrix properties to process chunks of the data and reducing the dimensionality, model was approximately 10 times faster. This approach would be more scalable when dealing with high volumes of data.